To the whole world, Java absolute beginners. As you can see, getting started on a new chapter now. So far, I've covered a chapter on Introduction to Computers, which was entitled Introduction to Computers, Java Programs in Java. Right, that was the name of the chapter. The one that I covered after that was entitled Elementary Programming, where basically we were dealing with variables and other things, such as operators. Okay, so and then I went on to what? To selections. And right now I'm getting started on this one here, which I happen to call mathematical functions, chapters, and strings. Okay, without any waste of time, let me jump straight to the very first exercise. Okay, as you can see, it's a geometry problem. We are looking for an area of a hexagon. Okay, so the area of a hexagon can be computed using the following formula. S is the length of a side. Write a program that prompts the user to enter the side of a hexagon and displays its area. So here is a sample run. Okay, this might look complicated if you are new, but once I'm done doing it, you would realize that there was nothing scary about it. Okay, so I'll go A. Of course, I do need a main method. Again, as always, I'll have to create a scanner to read user input. So I'll simply go scanner Luandiles scanner. Why am I doing it like that? It's just that I want you guys to know it's not required to always use the word scanner there. You can put whatever variable name you like. Now close scanner. Can go Luandiles scanner dot close. That's my name in case you didn't know, Luandile. Anyways, what else do I want to do once I'm done doing that? I want to prompt a user to enter a site. And I'll do that by simply going system.out print enter the site. Of course, it has to be greater than 0. Greater than 0. Okay. And I'm gonna store that on a variable called s. Of course, it has to be a double. So go run the scanner dot next double. Now that I've got that, the very first thing for me to do, a wise thing to do, is to make sure that s is greater than. Let me check out my formula. S has to be greater than 0. Right? If s is greater than 0, we can do the following. We can store. We can store the following. Store something in a numerator. Okay, we can store something in a numerator, and that something is gonna be called numerator. It's gonna be 6 multiplied by it's gonna be 6 multiplied by x multiplied by s again. So that is to say 6 multiplied by s squared, right? We can put the value of s there and then put it 2. Okay, so that is it for my numerator. Now as for my, I wanna store something on a denominator as well. Okay, denominator is equals to what? It's 4 tan pi over 4. Okay, so simply go 4 multiplied by tan math dot pi over 4. Okay, that will take care of that. Again, I'm not planning on explaining in words what's going on here. Ideally, we taking advantage of the math class, right? It has a bunch of static methods. Forget the word static. It has a bunch of methods that you can make use of. One of which is the tan method, which is used whenever you're working with tan. There are other ones as well, such as sine and cosine. There's a lot, you guys. You will see along the way. And if you want to know more, you can check out the documentation on the math utility class. Okay, what is it that I probably want to do? Okay, now that I've got that out of the way, I need to compute area and store its value. Area is equals to numerator over denominator. That's my area, right? As you can see. And then finally, stem dot out dot print. It's a good idea to use a printf so we can format our output the way we please. The area of the hexagon is, as for my field width, I'll put a 4 numbers to the left, spaces to the left. I'll then go after a decimal point. As for my precision, I'll go to F for my format specifier, and right there I'll go area. Now, what if this condition assumes that our s is greater than 0? So what if that is not the case? Of course, we can let the user know that you gave us an incorrect input. Error. Okay. Valid value of what? If I wanna go s, I can do backslash that and then put the value s there, and under backslash and then put a full stop. Let's see if this works. It should, though. It does not have any reason not to. Okay, let's try 5.5. 5,5. We get 4538, which is not what I expected. What could possibly be the reason? Give me a sec. Let me check out my values for my numerator. My numerator is 6 multiplied by s multiplied by s, right? 6 multiplied by s multiplied by s. We good there. And my denominator, as for my denominator, oh, you see, I forgot the 4. Damn. The problem is with my denominator. It's 4 multiplied by 10. Pi over 4. Exactly. That's precisely what I did. Then why are we getting an incorrect solution? Give me a sec, you guys. I'm gonna figure this one out. I really cannot believe this, you guys. Remember, I've been telling you guys this many times. I am no machine. I am prone to errors as well. You know, the reason why we have an incorrect solution is because the way it is because of this formula here, it's incorrect, you guys. You see that 4, instead of that 4 over there, are supposed to have 6, right? So that is absolutely why we've got this error at the bottom. You see, I did check out with the value 6. You know, all of these tutorials randomly get them from different books, right? And then I create a PDF and then I create my own PDF. As a result, I sometimes make a silly mistake as I'm creating all these exercises. Turns out that this is one of those cases. It turns out that this exercise 4.1 is no exception, right? I did make a mistake by putting a 4 there instead of a 6. Again, check this out. The only thing I changed in order to get that output there was that instead of a 4, you see, if we put a 4, and I go 5.5, we get this answer the one we did not expect. However, if I put a 6, what do I get? I get precisely what we expected. Okay, so it's either this right here is the problem, meaning I made a mistake by saying that this is what is expected as an output, right? Or that formula up there is incorrect. Right there, they're supposed to be 6. Either way, you guys, our algorithm works fine. Trust me on that, right? Everything is 100% about this. You can do it yourself if you don't trust me. So that's gonna be it for this tutorial, you guys. I guess I'm gonna have to jump onto the next guess I'm gonna have to jump onto the next solution. Okay, so that's gonna be it, you guys. I'm gone.